Hi everyone, in this video we're going to be going over the graph analysis skills that are required in the momentum unit of Physics 30. In impulse momentum graphing, you'll be given force versus time graphs, with force on the y-axis and time on the x-axis. The area under these graphs is representative of impulse because impulse is equal to force multiplied by time. So you might be asking yourself right now, why would you use these graphs to calculate impulse when you could just use your formula impulse is equal to F delta T? The answer to this question is that you can only use this formula when force is constant, which is a simplistic assumption in most scenarios. In the real world, oftentimes you apply forces to objects that are non-constant. For example, when you're kicking a ball, the force you apply to it changes through the duration of time which it is in contact with your foot. So a force time graph may look something like this, or even this. And notice in how all three graphs, the forces are not constant. Thus, the formula F delta T to calculate impulse is no longer applicable. Instead, you'll have to find the area under the graphs to determine impulse. So in Physics 30, you won't be asked to determine the area under a curve because that requires mathematical skills outside the scope of this course. You actually need to know integration, which is something you learn in calculus. So for this video, we will only deal with calculating impulse using graphs of geometric shapes. Moving on to an example. Analyze the graph below to determine the mass of an object accelerated from rest to 10 meters per second by the force described. So to start off this question, we manipulate the impulse momentum theorem to solve for mass. Doing so, we get mass equals F delta T over delta V. F delta T can be determined by finding the area under the graph. We do so by breaking it into simpler shapes. So we've broken the graph into a rectangle and two triangles that are mirror images of each other. And we find the areas of the components separately and then we add them together to find total impulse. To calculate the area of a triangle, we use the formula base times height divided by 2. However, since we have two identical triangles, we multiply this formula by 2, leaving us with just base times height. So the area of the triangles is equal to 8 newtons multiplied by 2 seconds, which gives us 16 newton seconds. To calculate the area of the square, we use the formula base times height. This gives us 3 seconds multiplied by 8 newtons, resulting in an answer of 24 newton seconds. We add our areas together to determine total impulse, resulting in a value of 40 newton seconds. So now we have all the information we need to solve for mass. F delta T is equal to 40 newton seconds, and delta V is equal to 10 meters per second since the object accelerates from rest to 10 meters per second. So that gives us a final answer of 4 kilograms. So that brings us to the end of this video. Thanks for watching and subscribe for more Physics 30 content.